let's look at problem 5 again, longest palindromic substring. So we have given a solution using dynamic programming. So here we would like to demonstrate the two-pointer sliding window method. So first I'll go over the statement of the problem and its constraints, and then we will analyze one example to demonstrate or fix the idea. And finally, we look at the code and test the special case and generic case again. So the statement is as follows. Given a string S, so we are required to return the longest palindromic substring in S. So here are two examples, and in the first example, the palindromic substring is BAB, which has length 3. Similarly, in example 2, it has even length palindromic substring. So the constraint is that S is not empty and its length is bounded above by 1000. So here the method we are going to use is the two-pointer sliding window method. So we have practiced quite a number of problems using this idea of two-pointer sliding window, so which you can check for other videos in this series. So here the main point for this method is that around each index or character, so we find the longest palindromic substring around it. So notice that the palindromic string can be a length even or odd. So let's look at example 1 just to demonstrate the idea. So S equals B A B A D, right? So around this index, so say 0, 1, 2, 3, 4. So around index 0, so I equals 0. So the longest even odd length palindromic string is 1. For even order, because they are not the same, so they do not have even order, even length palindromic string. So this one give a length 1. For I equals 1, so we have this index. The odd length palindromic string can be expanded from this one to here, has a length 3. But if you look at these two, they are not equal, so there are no even length palindromic string around this A. So we get 1, 3. For I equals 2, so we have B, right? So again, the odd length palindromic string is up to here, because if we expand the window again, so we get B and D, they are different. So the length is 3. And if we look at the third index, BA are not the same, so there are no even order, even length palindromic string around this B. So let's look at I equals 3. So in this case, the odd length palindromic string is length 1, because the two around A is different, and also A and D are different, so there are no even length palindromic substring around this index. So similarly for I equals 4, we get a odd length palindromic substring, that is D itself. So overall the largest is 3, so we return 3. So this is the example 1. So we are going to translate this analysis into code and below. So but we are using the standard two-pointer sliding window. So again, as our previous videos, let's make some preparation in step 1. First, we are going to initialize a result. So because the length is at least 1, so we can actually initialize it as S0. And also we need a maximum length variable in order to track the length. We can set it to be 1 or 0. Anyway, so we can put it 1 here because just to match this result, which has length 1. So once this done, so basically we're going to, for each index, we find the longest palindromic subarray around it. So let's look at step 2, standard iterate and check, right? So for I in range length s. So here basically let me introduce this variable n equals length s just for convenience. So we can use this n now, right? So first we are going to check to find the odd length palindromic string around this index I. So basically we want to see how much we can move the 2 pointers. Let's define the 2 pointers like this, I, and then we are going to check the condition. So we want to make sure, so we are in range. So the left is greater or equal than 0, and the right is less than n, right? So, and also if s left equals s right. So as long as this is the case, we can expand the left to the left and the right to the right. So first, basically, from left to right, we have a palindromic substring. Now we need to check length, right? So the current length will be right minus left plus 1. If this is greater than the maximum length, then we are going to update the maximum length by right minus left plus 1. And also we update the result to be s from the left to right, so we write right plus 1. So then once we done this, basically we are going to update the 2 pointers. So left, right equals left minus 1 and right plus 1. We expand in 2 different directions to make it as large as possible. So this is for the case for odd length. So now also we can consider even length, right? So in order to consider the even length, actually it's the same, but we set the pointers a little bit differently. So we set I and I plus 1, right? Then what we want to do is we also need to make sure this condition, same condition. So left is greater or equal than the 0 and the right is less than n. Then we just copy this part. So with that said, so for each of the index, we have checked the longest palindromic substring possibly around it, and then we have updated the maximum length, and then we also update the result. So now we just need to return the result. So we write like this. So now let's check a special case. So this is for example 2, and let's look at example 1. So we'll have, yeah, this is the BAB or ABA are both okay, right? So yeah, that's the case. Let's check the generic case. Yeah, so actually we can compare this solution with the standard dynamic programming solution. So it's the DP solution is also good to know. That's about it. Thanks.